what's new with this one? Oh, I didn't draw the boxes for the flowchart for you. Let's see. Let's write down the given statements first. And for those of you who write large, my comment is write the statement first and then put the box around it. That way it'll fit in the box. And that's given. Okay, next. A is the midpoint of MB. That's also given. Okay, what else do we have? Let's see. Let's mark that. What does that tell you? That tells you about the two sides. Midpoint means MA and BA are the same. So okay, so the two sides are the same. Put a box around it and say that's the definition of midpoint. Okay. We have two pieces of information. We need a third one. Do we have a reflexive? Oh no, but we do have vertical angles. So now again, angle A, you can't just call it angle A because it's the corner of two different angles. So we'll say angle PAM for the left triangle, and then let's see, DAB, and that is vertical angles. Okay, so now we have our three pieces of information. Boink, 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 and we have so we get two triangles, and it's the two triangles they asked for: PAM and DAB. And what's the reason for that? Remember, there's two angles in a side. Is it angle side angle, or is it angle angle side? Is the side between the two angles? No. If it was, it would be PA. So this is angle, angle, side. Okay. What? Oh, parallel. Here's a thing about parallel. Let me just draw it up here. If you have two parallel lines, and I'm actually going to extend them a little bit. If you have two parallel lines and you have a line that crosses them, you may remember from Math 2 that it creates, I like to call it zigzag, for it creates two angles that are equal. So these are called alternating interior angles. And you recognize them by doing a zigzag. So I'm going to do the zigzag again. I'll do it in this direction after I've written the given statement down. So first statement, AB parallel to DE. Don't forget to write your little line segment signs down. And that's given. Okay. And so then the angle, let's see, I'll mark them in. Angle A is congruent to angle E. There's only one angle that is angle A, so I can just call it angle A. And again, that's alternating interior. And you have to say that the two lines are parallel before you can use it. Now, guys, there's another pair of alternating interior angles. I can go this way and get angle B to be the same as angle D. Because that's a second line. Line BD is crossing the parallel lines also. Okay, we could get the two angle C's, but angle is not a theorem. Oh, we have to go for another given statement. C midpoint of AE. That's given. And we'll use the definition of midpoint. So midpoint of AE. So make sure you mark in the AE part of it. Okay. So C is cutting AE in half, so AC is the same as CE. And that's the definition of midpoint. And now we have three pieces of information, and it is angle side again because AC is not between the two marked angles. So triangle, let's see, I'll just do it in order. Triangle ABC is congruent to, be careful with triangles, you have to put them in the second one in the same order. Let's see, what corresponds to A? On the other one, alternating interior says it's angle E. B is the same as D. And then back to C. And again, that one is AAS. Now, that's not what we were trying to prove. We use CPCTC to say that the pieces parts are the same. Get used to CPCTC. Corresponding parts of congruent triangles are congruent. It's very common last step.
I forgot to put the little segment signs over BC and DC, so why don't you do that too?